is visible?
Yes.
Yeah. Okay. Yeah. So I am an instructor at Sprintzeal, where Sprintzeal focuses on multiple certifications, where we have huge number of certification trainings available across 80 plus nations around the globe. Till now, we have trained around like 2,600 thousands of students across globally.
You are based
And
in London or other country?
yeah, I'm based from India.
Ah, okay.
Yeah, and yeah, uh, so mostly our our solutions include where we provide is employability, that empowerment, as well as health sector engineering. Okay, and project management, digital marketing, cybersecurity, information security, service management, quality management. These are the top domains where Sprintzeal focuses on. Um, Hopping on to AWS certified developer certified, right? We will have will go through how what is AWS, what is cloud, okay, and we will have an overlook of all, like most of the services that will be included in AWS Certified Developer Associate exam. And once we go through an overview, right, we will again deep dive into each of those services specifically. Okay, so what we will learn in this course? We will be learning how you will be able to define what is cloud computing, what is main events of histories, what led to AWS where it is right now. What is you can describe what is AWS platform, what all services it provides, understand its global structure, its security, describe what AWS services are. Okay.
Okay.
Basic concepts of cloud computing. Okay, here what is the benefit of it? As I said, right, it is easy to access. It is on demand. You whenever you want, you can create a system, and when you don't want it, just delete it. You will be free. You don't have to buy the whole system for its whole lifetime. Okay, so it is pay as you go system. You can focus on the core business, like you definitely focus on developing the app. You don't have to like be dependent on the infrastructure. You don't have to worry about the infrastructure. The infrastructure will be provided by the cloud providers, and you just have to focus on the business part, like to build the application, to build the features around it. So let's suppose you have a web application. So you can just focus on building that web application. You don't have to focus on any of the infrastructure side, and you don't have to think about how we can scale that application once the user demands get high. So everything on the infrastructure side, you can handle it on AWS, other than application end. So if you have infrastructure like IT infrastructure on site, right, on premise infrastructure, your main focus tends to shift to 70% to infrastructure, and only 30% to core business like developing and building those apps, because maintaining infrastructure also requires a huge cost, and dedicated persons like specialists who are intelligent and know about how to develop that particular platforms, right, the networking and all. uh, when let's suppose whenever the underlying hardware goes down, you'll have to check that what all things are going on. You'll have to buy that particular component, replace the component, the all that particular till the particular part gets replaced, right? Till then your application will be down. You'll have to wait if that particular part or the hardware is not available at the same moment, right? Whereas once you
Sorry
shift.
to interrupt you. Do I need any notes to take any notes or something, or it's not
Yeah, this is just an introduction. Yeah, this is just
Okay.
an introduction. Wherever you feel you want to take down notes, or if you have any doubts, we can discuss over it. This
Okay.
is just the basic what is cloud and why we
Okay.
use
Yeah, I
cloud
know, but I
technology.
mean,
Yeah.
during the course, the whole days, just need to
Uh,
write down something how it works, or just listening to
yeah.
you, and we're gonna make any exercises, any no, any example
Yeah, examples will be there. You have your
for
own
every service,
AWS.
right?
Yeah, correct. So AW, you have once you buy, you have bought this course, you have your own AWS account, right? Given by the team, right?
Okay.
Yeah, you can access that account, and we will going further, right? When once we start discussing about each service, right? We can go
Okay.
through those
Yes.
particular services.
Okay.
Yeah. So that is not an problem. So this is like a basic theory thing, like where you understand why we've shifted from in on-premise IT infrastructure on-site to cloud computing. Is it clear?
Yes, yes, yes. I'm
Yeah.
listening.
Okay. 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 So yeah. So what are the characteristics of cloud computing? What it is: self-service, network access, resource pooling, rapid elasticity, and measured services. So let's suppose you want to increase for a given particular in your own laptop, if you want to increase your memory, right? Memory in the sense RAM, you'll have to buy immediately a bigger RAM. Let's suppose it's 8 GB RAM. If you want to get it to 16 GB, you'll have to add an additional RAM on your own, right? Whereas in cloud, you can just shift from one instance to other, where you have more RAM, more CPU, and more compute resources, right? That elasticity is what cloud provides. It also provides network, particular if you want to have a dedicated network, you can make use of direct VPN, where a direct connection from the data center to your um particular organization, right? It will There will be a dedicated network set across that, and using that, right, you will be able to connect to the cloud computing services. Resource pooling. Let's suppose if you have multiple accounts in AWS, right? Those particular, let's suppose if you bought a reserved instance in one account, you can share that particular reserved instance in for a different account as well. You can share that particular resource. So yeah, that is one of the benefits of cloud computing. So we'll go each one in detail. That is self-service. Any type of cloud computing capabilities like load balancing, then EC, hosting, compute resources, serverless architecture. All those are provided in the cloud computing. It is at any time. You whenever let's suppose there is no a downtime or so, like if you want to access this particular service, you'll have to wait till that much point. Whenever you just log into your account and just start the service, that's all, without any manual intervention. So you don't have to, like, if you have like cloud, there are certain applications like um, Ansible, you have Chef, then you AWS proprietary service now called as cloud formation, where it will automatically create the resources without you going and setting up anything. So this is one of the benefits of making use of cloud. Again, there are network access over the network using standard mechanism. Like once you are connected to any of the ISP providers, right, you will be able to connect to any of the services or any of the resources that the cloud provider provides, right? The services, whatever we have, you can access it using laptops, desktop, mobile devices, and tablets. Resource pooling. So resources serve more than one customer, right? So while you just take an example of your laptop, when you are using your own laptop, at a time only you can use it, right? But in cloud, if you have one instance, that particular instance may be used by more than one users, right? It definitely you can access to that particular instance via network, and you will be able to, like, more than one consumer may be able, like, will be able to use that particular resource. Again, provides access, provider assigns and resigns virtual and physical resources. So whenever you create an EC2, like Elastic Compute service, that is one of the service, it will create the physical and the virtual resources, whatever it needed for you to access that particular service. So that is all handled by the provider. You don't have to go and manually set any IPs. It will be automatically created. Consumer has no control over physical location of resources. So you don't have the ability or the power to uh, like know where the data centers actually are. You will be just knowing, okay, these are the data centers, these are the areas, like the regions like AP South 1, or in London EU West 1. Um, there are multiple locations on the panel. You can have select one of the like regions and start creating this resources. That's all. So that is why it's easy to use. Then we have rapid elasticity. So describe how the service providers releases resources, enable enable scale out, scale in, based on the demand, right? Whenever you want, whenever there is a high surge in your traffic, right? Let's suppose your website is expected, let's suppose you have a Black Friday sale going on, right? And during that time, right, you have the ability to like, you don't have to go and increase the EC2 instances or whatever compute you have. You can have the load balancers and the auto scaling take care of it. So whenever you are expecting that there is a high traffic, you can just scale in and scale out. So the measured services. Customer measures the use of each component. So whenever, let's suppose, particular you are using a certain type of instance that has certain like characteristics, like 8 GB of RAM, 32 GB, 32 vCPUs, and other parts, right? Let's suppose you identify that these particular compute resources are too much for my application, and my application requires less number of RAM and the vCPU and the CPUs. So what you will do is, you will just scale down that particular instance type. So this we will be going through in our activities, and I will show you how we can do that. But yeah, definitely based on the application requirement, right? We can scale in and scale out the same instance type. Again, service and pricing are transparent based on how much hours you use that particular service. You will be getting charged for. Once you stop that particular service, the pricing stops immediately. Customer can manage and monitor their resources. So everyone, like, they can have certain alarms or certain notifications set. Once that particular limit is breached, they will be notified that for the current particular month you have been reached this particular limit, and you like, based on your decision, you can scale in or scale out, or you can stop that particular service. uh, any doubts till now?
No, no, it's okay.
Okay. um so
Of
yeah,
course, that I
just
need to read again this to understand again. I need to repeat to understand and to memorize. But till now, I
yeah.
understand.
So points, right? These points, once you start working on your services, right? Like, once we have once you create a certain labs, right? You will be able to know, like, okay, why we are using this particular services. So these are like, once you start getting the hands on, right, on the particular services,
Yes.
you will be able to know why these characteristics are noted as here.
Okay.
like resource
Okay.
pooling, rapid elasticity,
Thank you.
network access. Yeah, everything will be clear once you start using that.
Okay.
So based on those characters, right, we have certain benefits of cloud computing. Again, speed and agility, right? So at any point of time, you can create, let's suppose there is one requirement that at this like to build an infrastructure, right, at your own house or your at your own location, it will take certain amount of time, right? Like 1 month or 2 months, or it may be delayed because there are like resources are less, right? But on your by using cloud computing, it is as like as fast as your internet, right? Once you have logged into your account, you will be able to create the compute whatever you require, and you can start like deploying your application as soon as possible. And at the same time, it's just not you, there are like your colleagues or your team may also be able to parallelly do their work along your side. It's not like logged for your own uh, like for your own use. You can do that, but yeah, there is like we can do it parallelly as well to make it more faster. Reduce expenses. You don't have to like maintain a particular hardware for let's suppose if you have your own data center, right, you have to like maintain that particular components, particular like power and all. You will have to maintain everything. But once you are on the cloud, you don't have to worry about the infrastructure, or you don't have to worry about any of the underlying hardware failures. Everything will be handled by the cloud provider, and you just have to focus on your developing your application. So that is why that leads to reducing expenses. Why again we go on to reducing cost based on the application requirement, right? We can select a right type of instance, a right type of compute resources, where we will be able to like maintain that particular costs. There is no upfront cost. So once you logged into your like account, there is no cost, or you don't have to pay anything. Based on the utilization of your services, based on the utilization, how much duration you have used a particular service, based on that you will be getting billed for. Next is, you can go global within minutes. Once you have your application ready, right, deploying on a cloud is much faster than deploying it on your own data center, like from building it from the scratch to deploying your application. So it will like you can go global with your application within minutes. You don't have to like wait for certain resources to be uh, created. Lower maintenance, as the infrastructure side is maintained by the cloud provider, right? You don't have to maintain anything. So with the minimal maintenance on your side, that is only the application maintenance. Other than that, on the infrastructure side, you don't have to maintain anything. So these are the main benefits of cloud. And yeah, we can have reduced expenses like with cloud computing, heavy expenditures on data center servers, hardwares have been cut down. We'll usually need services and only pay how much we use, optimizing cost. It works like on a demand IT service, pay as you go pricing. So any doubts in any of these benefits, like why, like how and how, like why, what, and any of the stuff?
I understand the main idea. The main.
Correct. So can you just explain me what's the main idea, so like I can know for sure that that main idea is clear, like you have got that particular idea.
Sorry?
Like, can you just explain me like what you have understood so far, like so that I can be confident enough to go further, like proceed further.
Till now, we
Mm-hmm.
described the characteristics of the cloud computing and some
Okay.
of the benefits.
Mm-hmm. Mm-hmm.
And some of the benefits that we mentioned, we don't need to make some expenses and cost, like if we have one database, not cloud database, there are some decisions that we need to make, and there are some costs that we need to do. And in this case, we don't need to make this. That's why the main idea is.
Yeah. So the main idea is you have to focus, like you, whatever you can do it on your local machine, you can do it at scale with lesser cost, is the main idea, is the whole picture. So whatever
Can
you
you
can do
repeat
it,
it, please?
yeah, whatever you can do it on your local machine. Local machine being your, it can be desktop, it can be your laptop, or any other like device, whatever you are using it for to develop, right? So
Yes.
making use of cloud is like replicating the same thing, whatever you do at your local machine at scale. At scale in the sense, it can like on your local machine, it has a certain limit, right? Let's suppose you deploy a application on your local machine. How much customers it can sustain, right? Only 10, 5, max to max 50. Okay. But once you are on cloud, if you deploy application on your cloud, it can sustain like n number, like thousands and thousands of customers, without you having to like stress over like how much the compute is getting, like should I add more compute, should I add more RAM to it, should I add more memory, should I add more storage, right? You don't have to
Yeah.
worry about. These are the main benefits of cloud. And yeah, we can have reduced expenses, like with cloud computing, heavy expenditures on data center servers, hardwares have been cut down. We'll usually need services and only pay how much we use, optimizing cost. It works like on a demand IT service, pay as you go pricing. So any doubts in any of these benefits, like why, like how and how, like why, what, and any of the stuff?
I understand the main idea. The main.
Correct. So can you just explain me what's the main idea, so like I can know for sure that that main idea is clear, like you have got that particular idea.
Sorry?
Like can you just explain me like what you have understood so far, like so that I can be confident enough to go further, like proceed further.
Till now, we
Hmm.
described the characteristics of the cloud computing and some of
Okay.
the benefits.
Mm-hmm.
And some of the benefits that we mentioned, we don't need to make some expenses and costs, like if we have one database, not cloud database, there are some decisions that we need to make, and there are
Mm-hmm.
some costs that we need to do. And in this
Mm-hmm.
case, we don't need to make this. That's why the main idea is.
Yeah. So the main idea is you have to focus, like you, whatever you can do it on your local machine, you can do it at scale with lesser cost, is the main idea, is the whole picture. So whatever
Can
you
you
can do
repeat
it,
it, please?
yeah,
Um,
whatever you can do it on your local machine. Local machine being your, it can be desktop, it can be your laptop, or any other like device, whatever you are using it for to develop, right? So
yes.
making use of cloud is like replicating the same thing, whatever you do at your local machine at scale. At scale in the sense, it can like on your local machine, it has a certain limit, right? Let's suppose you deploy a application on your local machine. How much customers it can sustain, right? Only 10, 5, max to max 50. Okay. But once you are on cloud, if you deploy application on your cloud, it can sustain like n number, like thousands and thousands of customers, without you having to like stress over like how much the compute is getting like should I add more compute? Should I add more RAM to it? Should I add more memory? Should I add more storage? Right? You don't have to
Yeah.
worry about those things. It will be all
Okay.
handled by the cloud.
Okay.
So that's the basic gist of it.
Okay.
Okay. Yep. Okay. Yeah.
Just can you repeat the lower maintenance? Can I
Yeah.
read again?
Sure. 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 So lower maintenance. Since we implement cloud services, we don't have to maintain our own data centers and hardware, right? So as I said,
Yes.
once you bought your laptop, you will have to maintain its screen. Let's like it cannot be damaged, right? You will have to maintain its keyboards, its peripherals, its mouse, its memory, its
Yeah.
storage, right? That you will have like just think it on a bigger scale.
Yes, I understand. Thanks.
Yeah. So that is like you don't have to maintain any of your data centers, any of your hardwares. Everything will be handled by the cloud provider. Cloud computing has eliminated the cost of setup. So
Okay.
you buying the whole setup, right? You just buy a part of the thing. You don't have to pay like let's suppose a MacBook cost. Let's suppose a MacBook cost in Indian rupees is like 1,50,000. Or let's suppose in pounds it might be some £1,000, right?
Yes.
Yeah. So let's suppose you don't have to pay all the thousand pounds for that particular device. You can just pay how much you are using it. So let's suppose you are using your laptop just for your work purpose, like just from let's suppose from 8 to 5, right? And after that you
Yeah.
don't use that particular device, but you are still paying for the whole device, right? When you buy it for personal, like when you buy it. But on cloud, you just pay for like how much time did you use, like from 8 to 5 you are using, just pay for 8 to 5. Once you are done, you can just shut down your device on the cloud, and that's it, your billing will stop.
Okay.
Yeah. So that is what we meant, we mean for like cost of setup.
Okay.
And as on premise on premise infrastructure is no needed anymore. We don't need to spend on maintenance. Yes, Anna.
Yes. Thank you.
Yeah, yeah, got it.
Yes.
Yeah, feel free to ask, if it even if it is twice or thrice, right? Feel free to ask, and I will be happy to repeat it. Okay, no problem in that.
Thank you so much. Thank you.
Yeah. So yeah, just a small knowledge check. Okay.
Okay.
So yeah, what are the characteristics of cloud computing? You have the options.
Uh,
Yeah,
we have a rapid elasticity.
correct.
Measure all about
All of
all
that.
about.
Yeah, correct. All of the above. Yeah. So you have the explanation that National Institute of Standard and Technology describe five essential characteristics of cloud. So it's a like a standard, right? And those
Yes.
standards have to maintain by every cloud provider to to know it as a cloud computing. So it is on-demand self-service, then uh, broad network access, resource pooling, and rapid elasticity, and measured services. Measured services as being pay as you go. When how much you use, you pay for those only services. Okay.
Yes.
Yeah. So AWS overview. So first AWS was not a public cloud provider. Okay. First, like at 2004, right, it started a service known as SQS. It's a queuing service. What it will do is it will just queue messages like first in, first out. So that was the first official service that was launched by AWS in 2004. Later, it announced like AWS was officially announced to the public. Major being SQS as the service that was provided. In 2007, we had AWS had 175 developers. In 2010, it came with AWS moved away from Amazon.com and it created its own organization. In 2012, it had a first reInvent conference. In 2013, associate level certificates started, and in 2016, it reached around 10 billion in sales. So the major of the services were related to reliability, scalability, and uh, its dependency. Okay. Now AWS platform has around 200 plus services it provides based on it's depending on the user, like the application use case, right? We can use n number of services for each of those. Like we have multiple alternatives for the same solution depending on the application requirement, right? We will be people will be able to uh, use the particular service, that particular service.
Okay.
So we will be going through those major services, whatever are there, for and will be needed by the associate developer certification. But yeah, this is just the overview of AWS platform. Just a second. Yeah. So AWS global infrastructure. AWS is spread across the globe. It has many n number of regions. So here it is marked right in the orange globe. It is all infrastructure regions. So US, West, Gov clouds are just meant for the US soil. Whoever are there are certain compliances right for the application. So all the government that needs that certain compliance will be launched in the GovCloud region. Then we have Dublin, Frankfurt. Then we have Virginia, South Pole. Then Sydney, Singapore, India, Tokyo, China. Okay, US East one, Virginia, North Virginia. So there are huge number of regions that the AWS infrastructure is located at. Under this infrastructure, right, we have certain classification. These are the main things, like the regions, the availability zones, edge locations, and endpoints. Okay, so we'll go from one by one. Region, it's a completely independent geographic area. So when I say a region here by in the map, if you see, a region is Dublin, a region is Frankfurt. So both are independent geographic locations, right? India is one of the a region. Then we have Tokyo, then China, and again in Sydney and Singapore. Each are these are the regions what we call, composed of two or more availability zones. It region contains a set of AWS resources tied to a specific region. Okay. So going on to availability zones. In a particular region, right? Let's suppose in Virginia, we have multiple data centers in this particular region. Those data centers known as AZ. So within the same proximity in US East 1, we'll have multiple data centers known as, like, it will be marked as US East 1A, 1B, 1C, 1E, like that. Depending on how many data centers it has, it will have that many number of AZs in. AZs is a short form for availability zones. Okay. So you can see more than one data center inside a region. Availability zones are connected through low latency links, provide high fault tolerance or business continuity, deploy your application in multiple AZ in the availability zones. Edge locations. So edge locations are delivery content to end users with low latency. CloudFront, there is one service known as CloudFront, which makes use of these edge locations for faster content delivery. In AWS, we have more than 50, we have 50 edge locations around the world. So using these edge locations, right, we will be able to like give the particular, let's suppose, in London, right, let's suppose when you are using Netflix, for certain regions, right, only a certain type of content will be available, right? If you move out to US, there will be certain content that will be restricted in that particular geolocation. So that if you want to maintain that, right, you can make use of these edge locations where you can decide which content should be available.
Can you explain low latency? What does it mean?
Low latency. So let's suppose I you are in London, right, and I'm in India.
Yes. Yes.
So when we are talking over a call, it has to travel the whole distance from India to London, correct?
Yeah.
So it will take some time. Like even if we are not feeling that like it is in microseconds, we are not able to feel that lag. However, it has to pass multiple hop locations, right? First it has to pass to the like from my region, from India to main, like from my state to that particular country. From that country to multiple towers will be there, and from there you will be able to, like, my packet will be able to reach to you, right?
Yes.
But the same thing, if you are in India, right, there will
Yeah.
be less hops required for me to reach to you,
Okay.
correct? That is the
Yes.
low latency, like without having a major blocker in between us, right?
Okay.
Whichever reaches first, like without having the latency. Let's suppose it has a dedicated line. Right now, you have a ISP, right? That will be providing the internet, and I will be on my side. I will be having a particular ISP that is providing an internet, but it is not dedicated to me, to one person.
Yes.
It might have multiple users using the same service at the same time, right?
Okay.
And it
Yes.
might have it might like cause the bandwidth to increase, right? Because let's suppose I have a 50 Mbps of bandwidth, and in that there are multiple users, correct? It will,
Okay.
so to travel the same packet, first like whoever is in front of me, that has to pass first, then it will be my turn, right? Fashion that will create a latency in between for me to reach till you, or a parcel from India to reach till London. It will take some time because it's not a dedicated parcel. But if I am doing a dedicated parcel to you, it without any without going anywhere, it will directly reach to you with a low latency. So it's just the duration between the contact between two parties, like from one data center to other data center. So one of the example is, let's suppose you type www.amazon.com, right?
Yes.
Yeah. Once you type that website, it will take certain time to load, correct?
Yes.
Initially. But once you, like, after the first time, if you try it for the second time, what it will happen is, without like within a certain how much time it required for the first time, more less than that it will require for the second time, correct?
Yes.
Why? Because that particular content was cached in that particular in your laptop, or in your ISP, in your particular router, right? That values were cached. Because of
Okay.
that, whenever you request it, you will be able to, like, directly get that content. So that is the low latency what we speak here. So you don't have to wait for the buffer to get all the data from one location to other, and from there you will be able to load it. So for example, I'll just here draw it. So yeah. So let's suppose you are in London, okay?
Yeah.
And your whatever you let's suppose your application, whatever you are requesting, they have deployed. So the Amazon company is like they have deployed their application. Let's suppose in uh, let's suppose in US, okay, USA, okay. They have deployed, so their application is in USA, okay. Once you type AW Amazon.com, what it will have to do is it will have to go from here to the first location, like on the country level, right? And then from the main country ISP, then from here it will reach to USA.
Okay.
Okay.
Yes.
But for the low latency, what they do is they will replicate the same application near to your country, near to your geolocation. So so here you don't have to travel till USA. You can get the same thing in the same country itself, here itself. So this
Yes.
is the edge location. So what here we have is, so this is the edge location. So you don't have to travel from London to USA just to get the particular website for the application. The application might be in USA, but they have replicated using a particular service. They have made this application available throughout the country in London. So whenever you type it, you just have to you will have to from this edge location you will get the content, whatever it is.
Yes.
You don't have to, like this time has been reduced, right? So because of this time has reduced, we say that it is a low latency application.
Okay.
Okay. Uh,
Yes.
okay. So endpoints. Okay. Endpoints
Okay.
is same as the URLs what we type for like Amazon.com or certain multiple URLs what we have, right? Amazon.com, Facebook.com. Similarly, in AWS, for each service, right, we will have a endpoint to identify, okay, this is the particular service. So here, DynamoDB is one of the service in AWS. So it will have service dot its location, that is US West 2, and then its top level domain, that is Amazon AWS.com. This is the top level domain, and these are the subdomains. Yeah, any doubts here?
No, no.
Okay. So what are the benefits of global infrastructure? So we have like multiple global locations for deployments, right? You don't have to um, dependent on one particular region. You can have multiple. You can deploy the application at multiple locations. As I said, right? If you want to deploy your application in London, you can deploy it in the London region as well. You don't have to be dependent on the US regions. You have multiple choice to maintain and ensure data locality, low latency content delivery, as I said, and reliable domain name resolution. So once you bought the particular domain, right, from any of the location, it will be able to you will be able to get that particular domain. So as an example, I can just take one. So if you take, DNS, what is DNS, right?
No.
Okay. So let's suppose, how do like my Chrome, like my browser knows, like, okay, just a second. Yeah. How will my browser know like which server to reach when I type google.com? How will it know?
Sorry, how it will know?
Yeah, so let's suppose I'm just typing google.com, right? But
Yes.
on the compute level, we talk on the network level, right? Like
Yes.
like we have networks like IP addresses, right? IPv4, IPv6,
Okay.
right? So how will it know? How will this, like I'm typing it in plain English? Like if you in the computer terms, if you say that it is in the plain English terms, right? Google.com.
Yeah.
But how will it know to which particular IP we have to reach, which particular machine we have to reach to? So that
Because
will
of
happen,
history.
yeah, because of DNS. So I'll just show you one example, okay? So once I type here google.com and if I search, it will load and it will show for which particular region, which IP it will reach to. Okay, so here, if you can see in United States, San Francisco, we have this particular IP. But
Okay.
in Mountain View, CA, in the same country, we have a different IP.
Yes.
Correct. These are the IPs. These are the particular. If I copy and if I just search this, see, I got a google.com, right?
Yeah.
Did I have to like write google.com? No, right?
No.
Correct. But these IPs, right? It is hard to remember for human beings, right? We don't like we don't know like let's suppose we don't have to like remember 142 to 250 80 110. These are the public IP addresses, IPv4.
Okay.
You're getting it? Um, like these are the IP addresses what you have, right?
Okay.
And these are the like server IP addresses where this particular application google.com is working, like Google application is loaded, right? Just to maintain the latency, right? Like to get to, let's suppose in this region, like let's suppose I can take London region. Where is London? Okay, London we don't have.
Maybe it has Dublin. Dublin.
Yeah, UK. You have UK, United Kingdom. Yeah. So see here, these are the set of IP addresses where based on the location, right? Let's suppose here Spain, we have a different IP address. Then here Dublin, we have a set of different IP addresses. Here United
Okay.
Kingdom, we have a set of different IP addresses. Every IP will be working on the same, like you will get the same this application. There won't be a different application, but just for the customers to load it faster, right? To get it faster, we have these multiple addresses. Like these are the edge locations for Google, you can say, so that they can get google.com much faster than whatever. So let's suppose if you want to search anything here, let's suppose if you search DNS search here, it will take some time to load. But if you are connected to like if I am connected to Indian server, right, I will get a response much faster because I have like I am connected to the server which has lower latency, which has to travel less to get the same answer. Am I making sense, or is it like
Yes, yes, yes,
confusing?
yes. But it was something new for me.
Okay, got it. Yeah. I would require some confirmation from your side as well, because if you don't say anything, right, I will by default I will assume that you don't understand, like you are still confused in that part. Okay.
No, I understand now. It
Okay.
was just
Yeah.
new information.
Correct.
So
No problem.
DNC stand for, can you the different how it DNC for what
DNS.
the full DNS for?
Correct.
Sorry,
DNS stands for domain name server.
domain, yes, domain.
Name server.
Okay,
Okay. So
yes,
what domain name server does is it will have a mapping of these particular services. So it
okay,
will have a mapping of google.com to this particular IP in
okay,
United States. It will have google.com mapped to this IP in this particular location. So for each location, right, it will have a mapping. It will have a map like a table.
yeah.
So
So
here,
Google will have different IP address for different country, for different locations.
correct. Same. Yeah,
Okay,
correct. And because you don't have to decide like which server you should connect to. So let's suppose
okay,
you are in UK region. You don't have to like specifically mention that okay, let's connect to this particular UK region itself. You can like you just have to type google.com
okay,
based on your geographic location, right? It will connect you to the lowest latency server where you will get the
okay,
responses much faster.
okay.
Okay.
Yeah,
Yeah. So that's the gist of it, the DNS. Okay.
okay.
Mm,
Domain name server. Okay,
domain name server. So we
okay,
have some basic terminology, scalability. Okay.
okay.
Uh, you understood this, right?
Yes, yes, yes,
Reliable
yes,
name server. Okay.
yes.
Now we have terminology. The basic terminology that we use at like in cloud services, right? Scalability, able to handle increased workload by expanding accordingly to the load. Okay.
Okay,
So
yes,
what does this mean? So it means that let's suppose at certain peak, right? Let's suppose in morning, your application will not have more than 100 users, right?
yes,
So it will maintain that particular amount of servers itself. Like it will maintain one server, two servers based on your particular whatever configuration you have set, right? It will maintain those many servers. At let's suppose at noon, you know that we have a huge amount of customers visiting our website. At that point of time, you will be able to scale up the number of instances that you have from two to you can go to 10, 100, thousands within seconds. Okay. So that is we known as scalability. We can scale. uh, then we have fault tolerance. So what fault tolerance is? Let's suppose you are one of the server what you have configured.
it's the
Yes.
same terminology that we use in not the same, but similar to the microservices.
Microservices. Yeah.
Yeah, in Java.
Correct. So let's suppose if like the two of your microservices are doing the same task
Yeah.
and one of the pod goes down,
Yes.
then what happens is the other should be able to serve the traffic irrespective of the second working or not. Correct?
Yes.
Yeah. So that is fault tolerance. Again, elasticity. Elasticity is like scaling up and down. So that particular compute resource, right? Like for the pod, if you have the pod, right? For a pod to like change the memory, you have to delete that pod and again recreate with a new memory, right? Like you will have to like
Okay.
change that particular configuration and recreate that particular pod, right? But in
Yes.
here in like in cloud computing, we don't have to like delete that particular instance and then scale up. You can scale up on the fly, like on the go. If you want more compute resources, just you can the same compute. Like let's suppose you have at start you didn't think that your application can scale will require this many amount of RAM. Then and that's why you created a compute resource which has only 2 GB of RAM. But later you based on the traffic you have, you thought that okay, 2 GB is not enough, we require 4 GB. So you don't have to terminate or you don't have to delete the whole thing from the cloud. The same 2 GB compute resource can scale up to 4 GB as well. That is the elasticity the cloud provides. Durability. So the durability will means the underlying infrastructure, right? It will stay strong or in any condition, right? It will be able to serve you without any interruptions. So if let's suppose in any of the region, if you are facing some storm or anything, even if that is happening, your services will be still up and running. That is the durability the cloud provides. Okay, if there are any power cuts as well, that also will be handled by the cloud provider. Availability. Continue to operate and provide the same services as it is originally did. Right? So let's suppose as like if you have created one, let's suppose your device, you have bought it for like 5 years back, and now if you are using the same device, it's not giving the same performance that it was giving you 5 years back, right? But at in compute, like in cloud, the same instance will be able to in the same compute will be able to give you the performance as it was giving when it was bought at the first time.
Okay.
Okay. Yeah. So that is the promise that cloud providers provide. So just like once more, scalability,
Okay.
fault tolerance, elasticity, durability, and availability.
Just
Okay.
1 minute, please. I need to write them.
Okay.
Okay.
Okay. Yeah. Just a knowledge check. Define an availability zone. It has one or more data centers inside a region. One per
Yes.
AWS region provides high tolerance or business continuity.
All above. One or
Mm,
more data center inside a region is true,
yeah.
right?
Mm-hmm. Mm-hmm.
One for AWS
Region.
region. I don't think so.
Mm-hmm.
Provides high fault tolerance, or this is true.
Okay. Okay. So A and C is true, right?
Yeah.
Okay. Let's see the answer. Yeah, you're definitely correct.
Okay.
So yeah, I am more happy that you are able to answer this. Okay. Like so definitely availability zones are the physically separated data centers. Okay. Within a
In
typical
sorry,
metropolitan
just to ask, in exam there will be a question like that,
no,
or
these
depends?
are just for your concept clearance.
Okay.
Exam
Okay.
questions are like different type. So they will
Okay.
be judging you on the application side, like the resource. There are multiple services, right? Based on those, but these are the common terms that will
Okay.
be
Okay.
again and again used in the cloud computing
Okay.
area. So you should have this
Just the
clear.
beginning.
Yeah,
Okay.
yeah, yeah. So here, as I said, right, this like availability zones is nothing but a data center within a particular region. So if you select London region, in that London region, there will be multiple data centers located within that particular proximity, within that like 300 meters or 5 kilometers, like that. Okay.
Okay.
Yeah. Located in different sections of metropolitan. We already know that availability zones are isolated and are independent of each other to provide high tolerance and business continuity. Okay, it's just as as the saying goes, right? Not to put all the eggs in one basket. It's same in that particular analogy you can use.
Okay.
Yeah. So we'll go around like then overview of what all services we have. Okay, and in
Yes.
AWS. For networking, we have virtual private cloud, also known as VPC. For as we discussed, right, we have DNS. For DNS, we have in AWS service we have Amazon Route 53. Okay.
Yes.
For networking, we have like as I said again, direct connect. So direct connect in the start we discussed, right? Like if you want a dedicated networking from your organization, let's suppose XYZ, you are working in XYZ organization. From that organization to AWS to particular region, if you want to have a direct network connection, you can make use of AWS Direct Connect. Okay. VPN is as like however how we use regular VPNs, right?
Yes.
Same VPN like encrypted. All the communications are encrypted from your local machine to the AWS. Okay.
Okay.
But it won't be having a dedicated network, right? It will be its own like on the over the internet, but in the
Okay.
encrypted format. Then we have elastic load balancing. So let's suppose on uh, what we can say in multiple clouds, right? As I said, are you familiar with Kubernetes by any chance?
No, actually.
Okay. So
My
in
next
microservice,
my next move will be on that to understand that, but no.
okay. That's good. We can like here on that also we have. But let's say why
Yeah,
I
but
am
it's a little
talking.
bit expensive.
Correct. Currently,
Let-
why I'm talking about load balancing is because um, here, right, as an elastic load balancer, um, let's suppose you have multiple compute resources, right, and they are all running on same application, but you as an user you don't have to like remember all like each individual compute resources, right? Like let's suppose this is IP1, IP2, IP3. You don't have
Yes.
to remember IP1, IP2, IP3. Okay,
Yes.
it should like whenever a user comes, they should only know IP, right?
Okay.
And by what this will do is it will transfer the load. So let's suppose it will transfer the loads automatically to the IP1, IP2, IP3 based on how much idle they are. Correct?
Yes.
So this is the one of the service that we use. So this is load balancer. Then
Okay.
we have auto scaling. So as I said, right, you can scale up and scale down whenever the load increases, right? So here we make use of auto scaling. We have a service known as auto scaling that will help us to scale up the instances or scale down the number of instances in that particular in that particular region, right? If you want to have at any point of time, if you want to have 10 compute resources, then this auto scaling will make sure that you will have 10 compute resources at any point of time. Or if you want to scale down, if you want to have 5 or if you want to have 2, this auto scaling will select that particular compute and will maintain that. Okay.
Yes.
We will have this all in the greater detail, once you have the lab, right, we can have a simple like a lab thing, and we will be able to do the particular things, right?
Okay.
So you'll be more familiar, like what and how we are used to.
Yeah, it will be more simple for me to understand.
Yeah, correct. Because like engineers know, like engineers don't get it by just hearing it. They have to do it on hands. Unless and
Okay.
until they do it on hands, right, they won't be able to grasp that particular concept. And me being an engineer as well, right? Most of the theories, it goes all like a bouncer to me as well. But yeah, definitely, once you do a hands-on, right, I will again the concepts will be more clearer.
Okay. Okay.
Yeah, just a second.
This PDF material, I will have it, right?
Yeah, you can talk with the POC of this Sprintzeal, whoever,
Okay.
and they will be able to share it with you.
Thank you.
Just a second, Nimrod.
Yes.
Sorry for that. Yeah. So again, here VPC. Like again, we'll go like just a brief introduction of each of the services.
Okay.
So in networking, VPC, a virtual network that closely resembles a traditional network. So you have subnets, you have a particular we like in that particular subnet, you will have certain set of IPs, right? Are you familiar with the concept of subnet?
Sorry, subnet.
Subnet, yeah.
Uh, I have finished informatics about 15 years
Mhm.
ago, and there.
Okay. I can just give you a visual thing of subnet. So this. So let's suppose this is your network, right?
Yeah.
This mesh is your network. Okay. Or
Yes.
much more clear is this. Okay. So let's suppose you have one router. Okay.
Okay.
In this router, this may be connected to multiple systems, right? Here you have this
Yes.
switch. A switch, what it will do is it will just relay the information from one area to other. So in one organization, let's suppose this is one finance organization, then you have billing organization, then developer, and then management and everything, right? So they have their own dedicated networks in their own mesh. Okay. But let's
Okay.
suppose if one department wants to talk to other, right? They will require a router, correct?
Central, yeah.
Yeah. So this router will have a certain subnet, certain set of IP addresses. This is one subnet. So
Okay.
200.200.10.0/25.
Okay.
This will be one subnet. So how will you calculate the number of IP addresses? That will be 25 minus 32.
Okay.
So 25 minus 32, it will be, you can just say here 25 minus 32, 27, right?
Yeah.
So 2
1,005.
raised to 7. You will have to do 2 raised to 7. That many IPs will you will have for this particular router. So
Okay.
that many switches can be added to this router so that they can communicate with each other. Got it?
Yes.
Yeah. Similar, this same architecture can be replicated in cloud using VPC.
Okay.
Okay. Yeah. So every resource you create, so let's suppose every resource, whatever load balancer, yeah, like compute resources, whatever you create within this particular private virtual cloud. You create everything within this particular private area, whatever you have in that particular account. So in one particular account, you can create multiple VPCs. So if you have a requirement, right? If you want to, again, here, if you let's suppose this is one VPC. Okay, this is one VPC. This is another VPC. This is one other VPC. This is one VPC, and this is one VPC. All the resources within one VPC can talk to each other because it is all connected via switch.
Okay.
But if a resource from one VPC wants to talk to another, there is one more service in AWS, that is transit gateway. You'll have to make use of that gateway, it will be similar to a router that will help us to connect one VPC to another.
Okay.
Understood?
Yeah.
Okay. Provides isolated virtual private network in AWS cloud. Okay. So this will be like you unless and until you have any network gateway, right, attached to this particular VPC, you won't be able to connect to the internet. Okay.
Okay.
Yeah. Next is Route 53. So here, highly scalable and available cloud domain name system web service. So here you can create multiple domain names, and you will be able to map that particular whatever resource you create in your like EC2 or any of those services, right? Wherever you create that particular value, you can map it here using the domain name, and you will be able to like just type out uh, let's suppose like amazon.com, right? It will be able to route to this particular resource directly. Routes request to AWS infrastructure components. Migrates or transfers existing domain to Route 53. So you have multiple domain providers. Those are like GoDaddy, or there are multiple where you can buy that particular domain. So if you want to see this, so here, right? So let's suppose if you want to search for Anna, right?
Okay.
So here, if you see, Anna.com is already taken, right?
Okay.
Someone has taken this, and see, the broker fees is like 1700 in Indian rupees. But you have this particular ana-info.com. Okay.
Okay.
Once you buy this domain, right, what you will be able to do is whenever, and you will do like here in this domain, in this Route 53, once you add this particular domain, right, this particular domain, whenever you type ana-info.com, you will be redirected to a site. Right now we don't have any compute resources behind
Okay.
this domain, right? Because
Okay.
of that,
Yeah.
we'll see we are not able to find that website.
Okay.
But once you buy this and you add those particular resources, you will be able to see this as well. Okay, just as your local machine. Like if you try with 127.0.0, right? This you'll try with this currently. This is your local loopback address, right?
Okay.
Yeah. So if you do this, you will be able to search it, because but here also I'm not running any service, so because of that you're not able to see anything. But in a similar fashion, on the internet, if you buy this domain, you will be able to create a website for your own.
Okay.
Okay. That is why we use Route 53. Okay. To map the particular resources to the domain name, whatever we have. Okay. Then we have Direct Connect. So Direct Connect, as I said, it establishes dedicated network connection from your organization's network to AWS. Because of that, it bypasses the public network. So it once you are connected using Direct Connect, right, you don't have to go through internet. It's just like a LAN cable how you connect to the LAN cable, right, from one to another, using your own area. Same as that, over that LAN, how you talk. Similarly, you will be able to communicate with those resources to AWS from your local servers or local system to AWS using direct connect. Okay, receives high bandwidth and predictable latency.
Okay.
Predictable in the sense, like, you will be able to know, okay, we have this much amount of bandwidth, so it will be like, okay, we know the latency will be this much, like 10 milliseconds, 10 microseconds, based on how much bandwidth you have, like how much bandwidth of connection you have taken. Okay, then we have VPN. VPN provides secure connection between your VPC and the remote network. Again, it's not like it's over the internet. Okay, it creates a secure connection on to another network over the internet. It does not uses, like, it won't bypass any network internet as we have in direct connect, but yeah, this will be secure. It will be like encrypted network. No one will be able to bypass, or man in the middle attack, right? No one will be able to do that.
Yeah.
Yeah. Then we have load balancing. So, man in the middle attack, right? Just wanted to confirm.
Sorry.
You like man in the middle attack.
Can you repeat, please? I didn't understand.
Yeah, man in the middle. Man in the middle attack. I just type here.
Can you type it? Thanks.
Yeah, man in the middle. And you see here, man in the middle
Okay.
attack. So, man in the middle attack, this is like,
I don't. First time that I.
okay. Yeah. So, man in the middle attack means that you and I are talking, right?
Yes.
Right. As of now, we both are talking. But what
Yes.
happens is, let's suppose, um, our conversation is, without we knowing us, there is third person that is listening to our conversation, that is eavesdropping on us.
Okay.
We don't want our sensitive data, like, to be like interpreted by any third person, right? We want it to be
Yes.
secure. Okay.
Okay.
Because of that, right, we make use of VPN.
Yes.
Okay, what it will do is,
Yes.
it will highly encrypt our conversation, so that even if someone tries to, even if the data gets leaked, right, because it is encrypted, no one will be able to unencrypt it, because the key, whatever it has, right, it is only shared between you and me. No other
Okay.
third person has that particular key.
Okay.
So this is why we make use of VPN.
Okay.
Okay. So that is what, like, just wanted to make you aware, like, why we use the VPN.
Okay. Yes.
Or you must have been like using it for quite a while, like, but still, just wanted to clarify that. Nothing else. Yeah.
Thank you.
Yeah. And we have elastic load balancer. So it helps get highly scalable application by automatically distribute the incoming traffic. So we only know IP. Okay, this the IP of the load balancer.
Okay.
That all the incoming request will be coming to this particular IP or this particular address. Once
Okay.
it drops to this address, this particular machine will decide which person it should route to. Okay, so that is the load balancing, the elastic load balancing. So supports EC2 instance type in same zone or multiple availability zones. Includes two type of load balancers. There are two types of load balancers. We have classic load balancer that is outdated right now, and we have application load balancer, which works on layer 7. You know
So
OS level.
a classic load balancer is outdated.
Correct, outdated. Yeah.
We don't use it anymore, or
Like we don't, AWS still has that option to make, like, to create a classic load
okay,
balancer,
yeah.
but that
But
does
they use
not.
more application load balancer.
Correct. So more
Okay,
features, more and modern features, whatever is available, right? Those are not
okay,
available on classic load balancer.
okay,
Everything is available on the application load balancer.
okay.
Okay, yeah. Then we have auto scaling. Auto scaling is like automatically resizes the computer cluster based on demand. So as I said, right, cluster. So here, this particular, let's suppose auto scaling creates 10 computers, right? 10 computers, we cannot like give like each individual person like, okay, like you use this IP, like IP to get connected to this computer, and all 10 computers will we will have to do it manually, right? To assign each IP to every person, that they will like use this for their development purpose. But we don't want that. So because of that, we use auto scaling. So it automatically resizes the computer cluster based on demand, increases and decreases the capacity of EC2. EC2 is nothing but a computer, virtual computer on the cloud. Okay. Like it detects unhealthy computers. Let's suppose if that particular computer's underlying hardware is like faulty and it's not able to sustain, is like it's degraded, right? It will replace it with the new one automatically without any manual intervention from our side. Okay, these are the like the network resources or the network services that are necessary for our developer certification. Okay, then we have compute resources. In compute resources, we have EC2, Elastic Beanstalk, Lambda, and container services.
I was
So,
thinking with myself why you didn't mention this, but these are computer services, right? Not
ha.
network services. Okay.
No, these are the network services. Network
Yeah.
services will be VPC, uh,
Okay. Yeah. I
S3.
understand now.
Yeah. So now compute, coming to the compute resources, we have EC2, Elastic Beanstalk, Lambda, and container services. Okay. So here, EC2 service, it provides scalable compute capacity like a scalable computer in cloud. Okay. So the full form is Elastic Compute Cloud. Provisions and manages compute resources or virtual servers in cloud. It scales up and down your capacity as demand changes. So you can scale and up and down based on the uh, demand or whatever you have on the traffic, right? A number of users that are visiting to your application. Based on that, you can increase or decrease. Okay. Then we have Beanstalk. Beanstalk is like a let's suppose ready to deploy model. So you have your web application, right? And you don't want to select which instance type I want to select, or which particular just yeah, or which particular network, or you don't want to like set up this load balancer, or right. What it will do is it is easy to use service for deploying and scaling web applications and services. Supports application in various programming languages, analyzes load uploaded code, and creates a required stack. So once you deploy your application, right, to Elastic Beanstalk, it will handle the underlying compute EC2 resources. It will handle the auto scaling, everything. It will be handled based on the demand on that particular application. So if there are more number of users, it will automatically scale the number of instances to from 2 to 10, or to from 1 to 10. Okay, based on it. Understood about the beanstalk? What
Yes,
is it?
yes, yes,
Okay.
yes. Once I
Then
tried to deploy one Spring Boot in Beanstalk, but for some reason I stuck.
okay.
I
No,
will
no
try it
problem.
again after finishing the
Yeah,
course.
definitely. Then we have Lambda. Lambda is, you don't have, like, it is a serverless service. What is serverless? Like, you just have to write your code and just run it. Just like how you run it in Visual Codes, right? Like your application in your Visual Codes, like on your local machine. Same thing here in Lambda, you will be able to run it. You just have to write your code in the particular supported programming format and just run it. How much RAM, how much memory, how much CPU, whatever is needed, it will be like it will be provisioning on its own. So here, if you see Lambda, run code
Yes.
without any provisioning or
Vision
managing
manage.
infrastructure components.
Yes.
Enable cost reduction since you only pay for the compute time when your code is running.
Okay.
Run codes for virtually any type of applications without any administration. So you don't worry about, again here also you don't worry about the underlying EC2 or so, right? You don't have to provision EC2 or Beanstalk or something like that. Whatever you just like as an IDE, right? You just type your code and run it. That's all,
Yeah.
and it will be able to run. If it is running on your local machine, definitely it will be running on your Lambda as well. There are no code like dependencies or so that you have to maintain. Then we go for container services. In AWS, we have two types of container services. One is AWS proprietary, that is ECS, and the second one is EKS. So ECS is based on Docker, okay, and EKS is Kubernetes. So for Kubernetes to maintain, right, we have like huge number of, like, we have to maintain the worker nodes and the control plane. So the control plane and the worker nodes, everything will be maintained by AWS. You just have to focus on your how much the underlying the pod level, the microservices. You have to uh, deploy that particular things. That's all.
Sorry, why is Amazon EC2 and EC2 again?
I think so. The when once you start
The
creating
first
the,
one, EC2, it's
yeah, EC2, it's a computer, virtual computer.
okay.
But here in containers, right, you will
This
for
one
each
is container. Okay.
container, this is container, EC2 container,
Okay. Okay. Not just EC2. Okay.
not just EC2. Here you will be working the application on pod level, not on the OS level.
Okay.
Yeah. So this will be like virtualization in virtualization. So here you will have one base image, one base OS, that is Linux, whatever it is, or Linux or Windows. And on top of that, again, you virtualize that and create containers, like create microservices on top of it.
Okay.
Okay. So this is highly scalable, high performance container management service, runs your application on a cluster of EC2 instances. So again, the basic building block is EC2. On top
Okay.
of it, it will be like running particular containers, like particular pods.
Okay.
No need to create, manage, or scale infrastructure related to cluster. It will be having its own auto scalings and all, right. So you don't have to create and manage it. Support Docker based applications.
Okay.
Right? That is what, like microservices, right?
Okay.
Yeah. So moving on. So up till now we gone through network services and compute services. Okay,
Okay.
two services. The third one is storage and content delivery. Okay, so you are
Storage.
running. Yeah, yes, Anne, you're telling. You were saying
Just
anything?
I want to write because
Sure, sure, sure. Please, please.
I memorize better when I write.
Yeah.
Old style.
Yeah, definitely.
Okay, you can continue.
Okay. So, yeah, once you start running your application, right, definitely you will have some data you want to store in, right? You want some redundancy. You want to store customers' information. You want to store the application state, right? Currently what the application state is. So you don't want, like, let's suppose your web application, once the user creates the particular user and the credentials, again once if he is like reaching out to you in the second time, the data should persist, right? So the data to persist, AWS provides the like there are a plethora of services that AWS provides, but major of them are S3, that is simple storage service. Then we have Elastic blocks storage. Then we have CloudFront, that is for content delivery. Then we have Glacier, that is if you want to store a data for certain amount of years, right? Like there are certain compliances, like there are banking applications where they want to store the data for 10 years, for 20 years, for decades, right? So they for to keeping in mind for the pricing, right? We have Glacier. Then we have import export snowball. So let's suppose you want to shift the, like you already have some data centers, right? You want to transfer petabytes or terabytes of data from that particular database, like from that particular on-premise data center to AWS, we can make use of Snowball. Then we have storage gateway. So this storage gateway, again, it will be used for like transferring the on-premise data to AWS. Okay. Again, we'll go in like a overview on for each service. So we have simple storage service that provides highly secure, durable, scalable, and economic storage. So all the things, right? Cost, then security, durability, and the scalability is maintained. Then we have it offers different storage classes to support various business cases, right? To reduce the costing for the storage, right? We have different classes which you can like select. Then we allows unlimited storage for any type of data. So here in S3, right, you can store videos, you can store images, you can store text files, JSON files, anything it can be stored. It's like you can make it, like, it can be used as a data lake. Okay. Then we have EBS. EBS is also known as Elastic Block Storage. So here, persistent block level storage that can be attached to EC2. So immediately for like how we attach hard disk, right, to our laptops. Similarly, we have elastic block storage for EC2 for our virtual computers. Okay, replicated for high availability and durability. Offers durable snapshots, so you can create this particular backups of this particular storage. Okay, and keep it. So whenever if you want for any circumstances, if that particular OS gets corrupted, right? It like we can have, like, let's suppose there is one of the computers got corrupted due to some virus, right? And you want to like you want to bring that particular data, so you can make use of this snapshot to get that previous data, whatever you have, and is designed for 99.99% availability. Three nines. Okay. Able to understand?
Yes.
Yeah. So let me know if you are not able to follow up. I can reduce my speed as well. Okay.
No, just after 25 minutes, just let's make 10 minutes off just to relax a little bit. It's okay that?
Sure.
Okay.
Once we finish this, right, like we have four more services. Once we finish it, we will have a 10 minutes break and we can continue
Okay.
from there.
Okay.
Okay, yeah.
Yes.
So CloudFront, as I said, right, edge locations.
Okay.
Previously we discussed about edge locations, correct?
Yeah.
Yeah. So to get that application to edge locations, from the region to edge locations, we make use of CloudFront. So what it does is, it's a global content delivery network service, delivers your web assets to customers in accelerated fashion. So again, as here in the diagram I said, right, here if you are in London and
Yeah.
the application is in USA, Amazon application is in USA, here in between, here in between, yeah, here in between you have content delivery network, CDN is a short form. Okay. So what it will do is, it will fetch all the metadata, whatever this application has, right? It will keep all the static data here in this particular CDN, the delivery network, in the edge location. So because it has to travel very short distance, okay, you will get your application much faster than getting the application directly from the USA site, okay, or from that particular region wherever the application is stored, okay, or deployed. So
Okay.
because of that, we have this CDN, and this CDN database is receiving huge number of write operations, right? And it is not able to scale up as the number of writes are increasing. But you don't want to lose the you don't want to lose this request, right? Or let's suppose uh, you have a number of yeah, you are receiving huge amount of traffic, okay, to this particular web application, okay, but here in this application, this EC2 or this compute resource was not able or was not designed to handle this much amount of traffic, okay. So in this case, what we do is, we create a queue, okay. So here we create a SQS queue, okay. What SQS queue will do is, so if this web application is not able to accept any of the new connections, whatever the client is able to do, right, what we will do is, we will send, or we will keep a queue of this request, whatever customer has created, okay. Once this application comes down, right, then we can have our application to queue this particular SQS, and to get whatever request during that period customer has made, right, we can do it like one by one, we can complete it one by one. So this is the main use of SQS, like a queuing service.
Okay.
So it's reliable, fast, and fully managed message queuing service, enables application decoupling. So here it decoupled the application, right? So here you don't have to like scale up immediately, like even if you are scaling up the number of instances, uh, immediately it won't be able to receive the traffic, right? It will take some time to get the system booted up, and then say application to be running. So during that time, if the application is not able to sustain that value, it can store all the orders here in SQS, correct? So it will be helpful. So it decoupled this particular dependency of increasing the number of instances at any given point of time. So it stores and passes the message or data between application components. It is highly scalable, and you pay only for what you use. Same for all the other services as well. Okay. SSES. We have simple email services. So cost-effective, scalable email services. So if you want to create a domain, right? Let's suppose you created anainfo.com, and for that anainfo.com, you want to create a mail server, right? So instead of you setting any custom mail server on your EC2 or on your compute services, right? You can make use of SES, which will give you directly by like a self-maintained mail server for you. Okay, and that you can use it to send mails to the customers or to create any subscriptions, right? Subscription mails to the customer. It can be sent for a bulk like a broadcast. Built by Amazon.com to serve its own customers. First, it was built for that, and again, it was made public for in AWS. Supports both inbound and outbound emails. So, if anyone wants to write back to you, they can use the same email ID and they can reach back to you on that same email. So, it creates like a maintain AWS maintained email servers. Okay, and you don't have to worry about the mail, the application configuration or not. You just have to take the domain name and you can start sending the mails to the customer. Then we have simple workflow service. It's like task coordination and state tracking system. So let's suppose if you want to like track any system status, right, or your application status, like if it is building or if it is like in parallel, if you want to create EC2 as well as RDS, right, you can have this particular workflows in parallel. Okay, helps to build and run batch jobs in parallel and sequential steps. Manages workflow execution and track the progress. Executes any programming language. So, irrespective of the programming language, this service can be used to create a workflow. So, let's suppose if you start an application, what all services you want to create, like EC2 and all, right? So that it will be handling that particular the here in the workflow, simple workflow service. Then we have simple notification service. So let's suppose once your EC2 instances like or your computer